Well, we'll go start with lifting the exponent. It's a very useful lemma when you wanna find exponents. Yeah. Okay. First we have some factorizations. Do people all know this?
On the Zoom screen, like everything is
Ah.
You have to turn off mirror my video. Go to video settings. There's an arrow on the stop video thing.
What? Okay. Okay. Wait. Video settings.
And then turn off mirror my video.
Oh. Wow. Now it's readable. That's awesome. Yeah, guys, do we know this? Hopefully. Cool. Yep. And we can generalize this to any odd power, right? It's the first part of our handout.
Oh, this is the first thing we learn in algebra.
Oh, they don't teach it anymore in HSC, which is really sad.
They don't? Not even like...
They only teach like factorizing like quadratics.
Oh, what?
Yeah. At least for my school anyway. My school's bad. Yeah. Anyway, yeah, we can generalize factorizing odd powers this way. But why don't even powers work? Because when you try to write something of this form, you get a3 minus a squared b plus ab squared minus b cubed, which makes no sense. Because this is a minus, and you're gonna get a minus b4 at the end. Which, yeah, we don't like that. Oh, how do I rub out?
This one. Can you use the paper towel for that?
Okay. That's for addition of two odd powers. We can also have difference of two powers. Right, we can have an minus bn. This one you can actually just write it for any n. Because it's always divisible by a minus b, right? And then we can write this as like an minus 1 plus an minus 2 b1 dot dot dot. Anyway, we factorized it. And the lifting the exponent lemma is basically applying this factorization and then looking at the prime powers that divide. Okay, hold up. Like you always know this factorization, and if you have like a n k times b n k, then you can also write this, right? Is this true, guys? Because you just raise everything. Like, instead of viewing it as a n k to the power of b n k, you just view it as a k to the n minus b k to the n. Yeah, cool. Hopefully people understand this. And yeah, basically what LTE does is if we have like a power that's a multiple of different things, it's not prime, right? We can always apply this factorization, and through this factorization we can just look at like the prime powers that divide it. Yeah. Yeah, we'll see this, we'll see how to prove this now. Okay. So theorem 1. If n p wait. Oh. 1 p prime from p equal 1 p is prime divides x minus y. Do people know this notation? Yes. Well, that's true, but I was just trying to see if you guys knew it before. Have you guys like seen it before anywhere? Oh, okay. Yeah. It explains it in a handout, yes. It's just like a way. It's just measuring the number of prime powers that divide it, right? Yeah. Wait, and odd? No. This is because we can base it. Oh wait, another condition is p does not divide x and p does not divide y. So this would get us minus y and minus 1. Yeah. And we can look at this like modulo p, right? So okay, one thing we can write out is this. Can we see this is true? Because you're basically multiplying them, and then yeah, VP is kind of like logarithmic. Yeah. So we want to prove this equal to VP, i.e. we want to prove the other thing equal to 0. Yeah. Alright, hold on, let me get some more space. Do you guys have any ideas how to prove it? Like, what could you try? I'll first write it on the board. Do you guys have any ideas? I'll try to go off that, and then we can see if we can solve it. Okay. Yeah. Ideas, guys? We can modulo P. Yeah. Mod P. If we want to prove that it's not divisible by P, which is just equivalent to proving that mod P is not 0. It's not 0. Oh, yeah, right, okay. Okay, so what we do is we homogenize it. So we get, which is divide everything by a to the n minus 1, which gets us summation I equal to 0 to n minus 1, b on a to the n minus 1 minus I. Do we see this is true? Wait, is this true? Oh yeah, it's true, yeah. Okay.
Then you guys check that A was multi.
Oh yeah. It's A is coprime to P and B is coprime to P. Yeah. And we know that B on A is basically another integer in modulus. Wait, hopefully these make sense. Do you guys understand what I'm calculating? Yeah. C. Also, n minus 1 minus I is you can flip all the notations around because n minus 1 minus I is in there and I is also in there, so you can just flip the notation. So you get this, right? Can you see it? Yeah, cool. Yeah, then you do like some factorizing trick because this is equal to C. Okay, wait, hold on. C to the n minus 1 divided by C minus 1, right? So, okay, yeah. The roots are like the roots of Cn minus 1 without 1. Yeah? Wait, does that make sense? Because you're basically taking out C minus 1, so C minus 1 is no more a root, and C minus 1 isn't a root in this. And yeah, so now we can finally use the condition P does not divide N. And this means that how do I, okay. Wait, did I do something wrong?
I think this might just go back to where it started.
Yeah, I think so as well.
The usual way to proceed here is set A equals B.
A equals to B. Wait, that's just proving C equal to 1.
So, because P divides A minus B. Oh, I'm not sure what you're up to, but you're showing that you assume P divides A minus B, right?
Yeah.
And so A equals B mod B.
Oh wait, yeah, never mind. That's so true. Oops. Alright. Oh yeah, I didn't. Okay. Oh. Wait, also P divides A minus B, A modularly B. Oh. This is equivalent to sum I equal to 0 to n minus 1. B, okay. N minus 1, which is n minus 1. Right? Yeah. Oh yeah. Now we can also use the condition n and p are coprime. Oh wait, well yeah.
Energy.
Oh yeah, wait, there are other. Now this is just kind of obvious now because B is coprime to P and N is also coprime to P. So when you times these two together, it's yeah. Okay, so that deals with the first case. So yeah, like what I demonstrated here, the main technique to proving this, like few theorems. I mean, it's like a lot of theorems, but it's basically just one idea, which is just you factorize it and then you analyze the power of prime that divides like each chunk individually. Yeah. Okay, theorem 1.5. We can actually just prove it based on theorem 1. Prove with theorem 1. Does anyone want to try to see how you can do that? You can prove theorem 1.5 with theorem 1. If you have an idea, you can come up and write. Okay, do people want me to prove it? Guys, say something, please. Cool. Okay, I'll prove it. We have that AN plus BN. Wait, was it the other one? Okay. Yeah, I think the proof is still the same anyway. And then, so now we can replace B with negative B. And what happens is you see AN VP of AN. Yep. Right? So AN plus negative B to the N. Also, we're given that N is odd. Because for N even, you can't factorize it. First, yeah. And basically the idea here is also use factorizing, but instead you're like skipping the factorization by directly applying the first theorem. Right? And this gets you EP of AN minus BN. And now they're equal. Cool. Yeah. Alright. So that basically deals with the case when N and P are coprime, right? What if N and P are not coprime? And now we move on to our few other theorems. So to proceed with this, basically it's an induction proof. We still factorize it a similar way, and we use induction to prove that they share exactly like 1p. So we'll introduce like a lemma in a way. If P divides A plus B, then yeah. To prove this, oh wait, also P is odd. The theorem looks slightly different when P is even. That's why we don't really consider it for now. But it only looks slightly different. It doesn't look that much different. Again, we write AP plus -1 5 times A. Wait, do we see why this is true? Like the key thing here is the -1 to the I. So this is the factorization we had before, and -1 is just there to flip the signs whenever we like proceed term by one. Yeah, that makes sense. Cool. So now we analyze the the powers of p that divide them individually. So yeah, again, we want to prove. We look at what we want to prove. We want to prove this. So this is also equal to bpa plus b. This, right? So yeah, now it's equivalent to proving this thing. P divides this thing exactly once. Okay. Yeah. Okay. Also, we first start by using the condition that P divides A plus B. So this gets us A modulo equal to negative B. 1. And then we can rewrite our equation negative 1 to the A B minus 1. Do we see why each of these lines are true? Basically, you're just replacing the variable, right? Cool. Oh, yeah. Oh, and then we sum them all up. Oops. Yeah, and again, we apply the same reasoning. So now we know that in this case, we had n equal to p. So that means p divides n times by, b to the n minus 1. So yeah, now we know that at least one power of p divides it. Now we want to prove like no more powers of p divides it, because that's how we get the result we want, right? Okay, so to do that, instead of modulo p, we can do modulo p squared. I think. Yeah, cool. Alright. So how would we write the condition A modulo equal to B mod P in mod P squared? What do people think? How would you write this? Yeah. Okay. I'll tell you. Alright. So wait, no. Negative. Actually that's negative. So you just write A is modulo equal to wait, we can see this is true, right? Because when you modulo P, this is A modulo negative B. So you can basically, yeah, there are differences in multiple of P. And yeah, where k is an integer, of course. Yeah. Now we want to calculate right. We'll use binomial expansion because we have binomial. We want to expand it.
Alright guys, I need to go see a cardiologist. Excuse me for a second. Oh, I'm sorry to Oh, I just want to go for a sec. I should be back, hopefully by lunch, but you never know.
Yeah, so that's expanding. Wait, do we know binomial expansion? I hope we do. Yeah. Wait. Hopefully, wait, do you guys know binomial expansion? It's basically like if you have two terms and then you like multiply it to a power and then you can write out each term individually, right?
Yeah.
Yeah, cool. Alright. Yeah. Also, another thing about binomial expansion, because we can write CPI is equal to P factorial divided by I factorial, P minus I factorial. This implies that P divides all CPI for I not equal to 0. P. Oh, hopefully people in the Zoom see it there. Yeah. Yeah, but I mean, their Zoom's recorded. Hopefully the Zoom can't see it. Yeah. Wait, this is true. Yes. Yeah, because nothing else underneath divides P, so P just stays there.
Yeah.
Where's the rubber? Oh, there's the rubber. Okay, so now keeping note that we're modulo P squared, right? So that means we can take out anything, take away this is true, right? What? Oh, this is true, right? Because if P minus I is greater or equal to 2, then that means that this is going to be divisible by P squared, right? We're looking at like this term specifically. Right.
Yeah.
Alright. So yeah, this basically leaves us only 2 terms to write out, which is very cool. So like a tip here would be you can when you do binomial expansion and you're modulo P or P squared, modulo powers of P, as long as the power is low, you can like write out the terms, and yeah, that's nice. So you don't have to do that much calculation. I mean, you have to do calculation, but it's not, you don't have to generalize it. Yep. And so this basically gets us only terms remaining. Okay, wait, hold up, did I miscalculate? I think I'm fine. Okay, the only terms remaining are I equal to P minus 1 and I equals to P. This gets us CP minus 1 and P negative P minus 1. Oh wait. Huh. Oh yeah, no problem, never mind. I was blind. Yeah, and P divides this and P divides this. So again, we can take this term out, right? Yeah, because yeah, P divides these two. So again, modulo P squared, it's gone. And what we're left with is negative B to the P minus B to the P, which is modulo equal to negative 2B to the P. Yeah. And can you guys see we're done here for what we're trying to prove, which is that modulo P squared is non-zero because this is non-zero and this is non-zero. Yeah. Cool. Yeah, okay. So theorem 2.5 follows from theorem 1. Oh wait, no, sorry, I haven't proved theorem 1 yet. Now we basically have the induction, right? So we have AP plus EP. Yeah. How would you proceed to prove the entire theorem 2 with this? Right, this is like the main lemma in a way. Any ideas, guys? Thanks for the ideas, guys. You induct. Okay. So we want to inductively prove that BP and plus BN right. Base case BP. What? No. And base case is theorem 2. Right? Because theorem 2 just states when they're coprime. And then yeah, our base case is when we want to analyze it for when it's coprime. So yeah. Base case is done. Now we induct. Okay. If VP of n equal to k plus 1, we can write n is equal to p times by like n dash, where VP of right, you're taking a power of p out. So going from this, we have yeah. Okay, so this line, we apply the lemma. Yes.
Yeah.
Cool. And then now we apply the induction hypothesis, right? I'll just write it here, lemma and induct. This is equal to VP A plus B. And yeah, obviously this is equal to VP A plus B.
Yeah.
Ah, cool. Alright. And yeah, another thing to note is that something can't have infinitely many prime powers, right? Unless it's 0. And if it's 0, the theorem is obvious. You just do it. Yeah. Okay. What's 2.4? Oh, I think I proved theorem 2.5 instead of theorem 2. But anyway, they're the same thing. Okay, we'll just try the same calculations. So the difference between 2.5 and 2 is that we stated that n is an odd integer, right? Because that's what allows us to factorize it. And basically, you can derive 2.5 from 2, like by again subbing in negative b, right?
Yeah.
Cool. Yeah. So actually, we can't derive it back because again, we don't have the even case. We'll just do it here. Wait, no. We can do something. So again, we sub negative b. Oh wait, no. We do this. Yeah, this is true. You're taking out the maximum power of 2 that divides it, so n dash. This means n dash is odd. And proceeding from here, yeah. Now we can apply yeah. Yeah, because why? We have a2k n dash plus negative b 2k n dash. Right. Which VP this. Can we see why this is true? So this we apply theorem 2.5.
Yeah.
I proved it the wrong way, but it's fine. Now this is true because 2 to the power of k is coprime to p, right? Because we said p is odd prime. Yeah.
Yeah.
Okay, yeah. Now we'll go to when p is equal to 2. Okay. So for when p is equal to 2, we know that an minus bn. I think. Right. Well, you guys are all squeezing into one, so anyway, this is true because again, one of the theorems above. So yeah, using this, we'll still try induction, still try to induct. Wait, is that true? Yeah. Also, we have the condition 4 divides a minus b. Oh, okay, so this will be useful when we expand it. We'll say like v2 of n is equal to k, right? And then we'll have like and then n is equal to 2 to the k, or n dash, which is going to be equal to a to the n dash, the power of 2 to the k, minus b dash 2 to the k. Oh, I will introduce a lemma as well, same lemma. Okay, so we introduce this lemma, which again allows us to go through like an inductive argument, go down one by one. Oh wait, sorry, what's one here? Oh, wait. We use one thing that everyone should know, which is you can.
Yes.
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 Cool. Yeah. And we know that 4 divides a minus b. Firstly, a, b are odd, so a plus b is divisible by 2. Yeah. But we want to see how much, like, does 4 divide a plus b? A plus b modulo equal to a minus 3b, which is modulo equal to negative 2b, right? And b is odd, so this does not work. Yeah. Yeah, now we proved our lemma that we've introduced. Oh wait, then we need a lemma. Okay. Okay. We'll introduce another lemma as well, because this will be needed. Okay. Wait, this is true. 1, 4. Can we see why this is true? Because if these two are modularly equal under mod 4, then when you raise them to any power, it's still going to be the same modulo mod 4. Yeah. So now our condition is 4 divides A minus B. And then we want to find BP of AN minus BN. Okay, again we try to induct base case. N is odd. And the N is odd case is proven above because they're coprime, right?
Yeah.
Coprime is allows you to skip things. Alright, induct. And not. So yeah, now we look at B2 equals to like, again, set it to equal to K. And we can say, yeah, so N is equal to 2 times by N dash. Yeah. But our previous two lemmas tell us that this is actually just equal to 1.
Yeah.
Yeah, hopefully that makes sense. Because we claimed before that, firstly, this is divisible by 4.
Yeah.
And if this is divisible by 4, then this can't be. So,
Oh yeah, that makes
yes.
sense.
Yeah, like one of them has to. Yeah. So yeah, now we basically finish our induction, which is equal to AN, BN, A minus B plus B2 N dash plus 1, which is equal to A2 plus B plus B2 N. Yeah. Even integer. Okay, so theorem like 2.75.2, which is like, I guess the second part of this, you do the same thing, but instead of looking at A and B, you look at A squared and B squared, because you basically what you guarantee is A squared minus B squared is always divisible by 8, right? And if it's divisible by 8, it's divisible by 4, so we can apply theorem 2.75 again. I call them 2.75 and 2.75.2 because they're all the same thing basically. So yeah. All right. Do you guys get the proof of the theorem now? I hope you do. Cool. Let's see which problem should we try. We'll try 2 problems and then I'll go to the other handout as well. Let's see. Don't look at his. Do problem 4. Problem 4 seems fine. Well, guys, I already rubbed out the geometry diagram.
You shut the door back with my
That's
finger.
cool. Yeah, guys, give a try to problem 4. It should be fine. Do you guys have paper to try the problem? Wow, wow. Wait, how many per paper and pen do you guys have?
Hopefully,
Enough, I hope.
all the pens. So insane.
Huh?
Well, I'm the only 16.
Oh, okay.
All the natural ones.
I'll give you guys like 5 minutes and then I'll ask for some ideas. Hopefully that's enough time. What? Alright, I'm gonna come around to see some favorites as well. Let's try the problem. First try. Oh yes, it's possible. The hints? Oh my god. I'm sorry.
My bad.
Yeah. Oh wait, I read the problem before as well.
Oh my god.
If you get the solution, you can present. If you didn't get the solution, you can present. I'm pretty sure this problem was like probably a contrast problem before LTE was well known.
just when A is 1.
Wow.
What?
Don't say the answer.
It works for 0.
No, it says positive.
Oh.
Positive.
Oh, right.
Yeah.
You can write a proof here. We can.
So basically, it's the directly applied lifting the exponent lemma. Because you have the amount of like 3 that is divisible by is just 1, which is how many?
Yeah.
Plus and the bottom will always be larger than this unless it's 1.
What if we have like instead of 5 to A, we have like 20 to the A plus 1 over 3 to the A? How would you try this?
like 20 to the A.
Yeah. Wait, never mind.
That's the same thing.
Never mind. Yeah, wait,
That's
my bad. Oh wait, 80. We'll try 80 then. Okay, you try to explain this so everyone else understands.
Alright, so you directly apply lifting the exponent lemma. Because you use the formula, so you know it'll be however many. It'll be divisible by the amount of 3's the exponent is divisible by, plus 1. And that'll always be less than the amount of 3's the divisor is divisible by, unless the divisor is just 3.
I agree. But what's that?
Okay. Yeah, what about the second one?
The second one's just
No, wait, 81 is divisible by 4 threes.
oh wait, I can't count.
It's 9 squared, not 3 squared.
So
Wait, what?
it would work for 1, 2, 3, 4, and then 6.
Wait, it works for 6.
Yeah, because you get 4 plus.
V3 of 6 is equal to 5. Well, V3
What?
of 6 is equal to 1, so 4 plus 1, 5.
Yeah, I was not thinking there.
Don't worry. But like one
Yeah,
thing you can
it's 4.
see is that when you raise the power of A, guys, when you raise the power of A to really big, the number of A's that divide the top one
Will
is very
increase.
small.
Yeah,
It will
still
increase,
small.
but like very small amount.
Yeah.
Like in the handout I said it's logarithmic, but it's not actually logarithmic because you can't pick the walls.
It's just because the amount of 3's that divide the bottom increase every single time.
Yeah. And the top one increases like once every like a decade.
Yeah. Not how you say it.
Guys, problem 1 is harder. Guys, try problem 1. If you don't know the prime factorization of 2009, do it yourself.
This is your question. I don't know. So
Oh wait, I'll write problem 1 on the board.
factorization.
Do it yourself. Wait, don't look at the
It's square times 21 squared.
Well, guys, I would have put this on another page next time.
But like, we could have figured it out ourselves. It just saves time.
Will there be a
Nah.
next time?
I don't know, probably. When you guys get to senior, I'll mark your exams. So yeah. Oh, problem. But find all integer solutions. Oh.
Oh my god.
Oh wait, yes.
Just be down.
Guys, this is slightly harder. Also my hit is slightly wrong, so it's not that direct actually.
Which one do we apply?
So we press that.
Try them one by one.
Okay.
What?
Yeah, but the thing to note is that like it's really forcing a condition that you have exactly 7 to the power of z, right? Uh, oh yeah. So I'd say think about the process of how we proved LTE, which is the idea is factorization, right? And yeah, think about that when you try to prove this. I'll give you 5 minutes if anyone has any ideas. That'd be cool. Wait, don't look at all the hints one by one. Alright. So it's 4 I think the important thing here is that 7 divides 2009. And that allows you to apply LTE. But the thing is, like, okay, wait, I'll give you guys like 2 minutes and then I'll give it a hint. Wait, can people see the button? What? Then you want to do the visible by 7? No? What?
How do you deal with the 41 though?
Oh, 41 just ignore
Wait,
it.
why didn't we
Oh.
do it?
Just ignore it.
It seems like
Oh wait, I mean, there is a way which that comes in somewhat useful. Oh, I wrote the second problem wrong. Hold up. The second problem. Okay. The second problem is meant to say this. K divides summation. Bad child.
Okay.
Wait, yes, n divides. The second problem is meant to say this. I wrote it wrong because LaTeX had problems. Do you guys have ideas for problem one?
No.
Oh.
Use LT.
yeah.
Let's see how you. How do you?
Do you like?
It doesn't directly give you the solution. Right?
Which
You
theorem?
have to like factorize the power.
You can factorize it, but okay, I give you a hint. If you apply LTE, you realize that like x 2009 plus y 2009 has like 2 more factors of 7 than x plus y, right?
Yeah.
But the thing is, think about how big x 2009 is.
Yeah.
And so like it's too big to be like 49 times by x plus y,
Yeah.
right? So that good you agree, yeah. So that's where you look at like if you just factorize it straight away, can you like perhaps bound the size of x of y, or like bound the size of x plus y or something? Like, wait, I'll just write this. Like x 2009 plus y 2009, right?
Yeah.
v7 of this is equal to 2 plus v7x plus y, right? And then also we know x 2009 plus y 2009 is equal to x plus y times by like summation I equal to like 0 2008 xi negative y to the 2008 minus I, right? So this gives you that this is equal to 49. This function is equal to 49. Wait, can we see why this is equal to 49? What? Because, like, you're only adding 2 powers of 7, right? And you're saying it's an exact power, right?
Yeah.
So this has to be exactly 49.
Yeah.
But that does not sound reasonable, right?
No.
Okay, can we prove it? Like, for example, when does this already exceed 49, right? Try that.
But when does that exceed? As long as.
Oh, good pen.
Wait, when does that exceed 49?
Yeah. When does like the second part of it exceed 49?
Y equals y, it exceeds 49.
Yeah, that's true.
But the only solution here that would have. Is this positive integers or just.
Wait, I forgot.
You forgot. You didn't write positive integers.
Ah,
So then,
wait, no, it doesn't matter if it's positive.
Then you do have at least one solution with non-equal, including 0. You just put y to 0 and x to 7.
We can just ignore that solution.
Yeah.
But like, we can analyze the size of this, right?
Yeah.
And then, also in the sake that we're looking at all integer solutions, we might as well just change this to negative, because negative y, right? And then we just have this. It looks slightly nicer. But the thing is, this is still really, really big.
So just it exceeds any kind of power of 7.
Well, it will exceed 49 because it's like 2008 power, right?
Yeah.
So I'm pretty sure, like, except for 100, there's like no other solutions.
Yeah.
Or maybe there is, and I forgot.
Yeah. That's stuff.
Do you guys want to try one more problem, or should we move on to problem solving tips? Oh, do you guys? Okay, you guys want to try and make problems, alright? Oh wait, maybe try problem 3. Problem 3 is harder than problem 2. Maybe. Okay, problem 2, we have prove given integer. Oh yeah, so when we want to prove there exists infinitely many of something,
Yeah.
we can find a class of infinitely many things, right? We can just find the infinitely many integers, right? If usually when we prove existence, we just find the integers.
Yeah.
What?
Aren't there just infinitely many k that are divisible by n?
Huh?
Wait.
No, you're given the integer k, and then you
Oh.
have to prove exists infinitely many integers. And
Oh.
yeah. Why is it so hard to write latex? I'll give you guys like again probably 3 minutes before you can look at hints. The problem becomes less fun if you just use hints straight away. Oh my god. What? Oh wait, yeah. Oh wait, another latex error.
Wait, where?
What does that say?
Just
Ni to apply LTE to a prime of infinite.
no, do problem 2. The problem, not problem 3, not the main one. Oh yeah, for problem 2, you might try to start with like k equal to 2 or something. Oh, also it doesn't work for k equal to 1 for obvious reasons. And let me just write it. Do people have ideas on how to?
Basically ignore the fact that it's multiplied by k, because that won't affect square root.
Wait, no. I wrote the question wrong because latex,
Oh.
right? Yeah, that's the problem. Yeah.
That makes a lot more.
I'll go improve my latex skills later.
That
Oh, God. Let me check if I have any other text. Probably not.
Wait, for I think at least for even what you can do, you can just at least if k is even, then you can just use an infinite number of power of twos because we'll split it up into pairs of two that
Oh,
are
yeah.
divisible by two.
Yeah,
And just
that's
the
good.
power can do it. And have
But
the
doesn't
power
that also work for odd?
You may not be able to split it up into
Oh, yeah, right.
powers of twos.
No, but
Right.
it's only one specific modulo of 4 where it doesn't split up properly. Right? Because if you have
Oh,
1
yeah.
through 3, you can still pair 1 and 3. Also, that's a pretty good idea. Yeah.
Right, yeah, that one.
So you're probably left with proving like it works for 1 or 4.
Yeah.
But yeah, good pairing idea. Try to see if there's something else you can do with it. Do you want a hint?
Yeah.
Okay.
Knowing that pairing thing just doesn't work for that specific case.
But you can look at a different sort of. You can look at a different sort of pairing. instead of pairing like 1 with like 3 and then 5 with 7 and 9 with 11 or like some other way of doing this, you can try to pair 1 with k, 2 with k minus 1, 3 with k minus 2. And now what you look at is a specific power for it. You look at is a specific power of a prime that divides k plus 1.
all of them. Yeah.
So yeah, sometimes like even if ideas doesn't work, it's probably just like it doesn't mean it's entirely wrong. It's close. Okay. And the rest of the problems doesn't have any printing errors, so you can try them yourselves. Question 6 is harder than the rest, I think, because it's harder to start. But yeah, guys, we have more stuff. What is he playing, honestly?
He's playing Clash Royale, but he's garbage.
Oh. Wait, do you guys know super Clash Royale skills?
Please?
Oh, okay, don't worry about it. Anyway, yes.
What?
One of the IMO members last year was ranked 2 in Clash Royale in whole of Australia.
Oh, in whole of Australia.
Yeah, in all of Australia.
My friend was top 10 in like literally every single Supercell game in Australia.
Oh, damn.
I mean, he does play them like every second he has.
Oh,
He was like top 10 in every single game, which is cool.
yeah, you guys are good at Clash Royale. Grind.
Heyday, no, he doesn't want to play Heyday, right?
It ain't the best.
Okay, guys, we have more class to do. Alright,
Or do you play Clash?
huh? No, I used to, but then, yeah, I left because, it's hard. Spamming emotes is too funny. Alright, yeah, okay. Do the rest of the problems if you can, solve them. They're solvable. Okay, now we move on to problem solving tips that I've collected over my years. So, what do you guys think maths is?
Maths is you like think.
True. Give me some more ideas.
For this thing.
Well,
That's my interpretation.
structure,
Like no,
information.
like this is how no. Everyone sees maths differently. Like, give me your ideas
What
of
if
how
I
you
see
see
a structure?
it. I bet you don't. Okay. Yeah. Do you guys do maths at school? I hope so. Good.
How would you not?
Oh, there are people who don't, by the way. And after year 10, there are.
Yeah, you
Oh,
don't
yeah.
have this thing.
Not at my school.
Yeah,
All right.
probably not at.
Yeah.
Oh, I'm like school, you don't have to.
Okay. Yeah. In maths, you solve problems and you try to progress theory. This is generally something people do, right? But like over problem solving, I like again. This entire handout is very much my personal experience. You can take from it what you feel like is good, but don't just say you have the exact same thought as me because I bet you don't. Yeah. Like, okay. So in maths we play with like ideas, right? We have ideas that we can progress into like actual theorems, actual like statements. And what we do is we need to like give an amount of information in to get some structure out, right? Does that make sense in any way?
Yeah.
And when you don't give enough information, you're not going to get the correct structure. Like, for example, we can just look at, like, let's say, problem, let's say theorem, wait, which theorem should we look at? Yeah, let's say the main factorizing lemma of the LTE paper, right? Like, it doesn't work if we say n is even. That means we don't have enough information in order. Like if we say n is true for all integers, it's not true because there's a contradiction already.
Yeah.
But when we give it enough information, things would just come out when you like calculate it in a logical way, right? So, like, a lot of times with problem solving is for what I do now, like I didn't do this much before, but find this really useful now, is you try to see what information you can use, what information you have, and perhaps how you can use it. And once you have that, you basically have like an outline of the proof already, right? Because you already know what part of the proof you're going to use this piece of information, what part of the proof you're going to use this piece of information. Like remember when I proved this, right? Like summation I equal to 0 to like n minus 1 ai b n minus 1 minus I.
Yeah.
Is like modulo non-zero mod p squared, right?
Yeah.
Okay, so what we use here is a modulo equal to b, I think. And then we derive that this is equal to n times by n b to the n minus 1 minus I. Well, yeah, no, b to the n minus 1, right? The two pieces of information that we use here is b coprime, and the other piece of information we use here is n also coprime, right? Like imagine if either of these statements, if one of them is not true, this is not going to be true.
Yes.
So like maths, the reason I say it's structure is because structure is like a list of information you have, and you have to come up with a method in order to use them to get what you want, right? And this is how, like, when I solve problems and I have like an idea that I want to work through, this is how I check whether or not it works, right? I have the set of information, like the set of like what I'm gonna use already in my mind, and then I say, is this enough to solve the problem, or does there exist a contradiction already, right? Like if the method doesn't work, then there have to be already a contradiction, like a counterexample to what you're trying to prove. Does that make sense?
Yeah.
I hope it does. All right. So yeah, okay, now we'll proceed to the second part. Difficulty. Yeah. What do you guys think are some difficult problems? Don't give me millennium problems. Examples of difficult problems. Oh, thanks, millennium problems.
Oh, it's like the one that hasn't been solved.
I mean, there's one that's solved, right? Do you guys not know Poincaré's conjecture?
Yeah. But the rest are not solved.
Yeah, the rest, yeah, there's 6 not solved. So yeah, guys, remember to solve one of these in the future. Yeah.
Yes.
But like, let's say like a difficult problem, like in a contest, right? What yeah. What do you guys think is difficult about it, right? Which part do you get stuck on? Let's just say, like, just think of some hard contest problems you have, and then tell me what part you get stuck on, and then we'll try to see like if we can find like some pattern of like problem solving in there.
Math.
Wow, that's really informative.
Very insightful.
Yeah, come on, guys. Come on. Is he still playing Clash Royale?
No, he's playing Payday now.
I don't know what that is. Oh.
It's the best supercell game.
What?
No,
Yeah.
Clash of Clans is, but whatever. All right, yeah. But okay, like what part of a problem would you usually get stuck on, right? Like imagine like
The beginning.
Starting.
Figuring things out.
wow.
Like the hardest part really, once you know roughly what to go, you basically can do it usually. The
Yeah.
hardest part of getting that starting idea.
Yeah. What do you guys think? What do the rest of you think?
What he said.
What he said.
What he said.
Thanks.
What did I
That's
say?
really helpful.
You said what you said.
He said.
The beginning.
And
The
you
beginning, the
probably
middle,
did.
and the end.
The guy.
Wow. I wonder what I wrote in the paper. All right. Yeah. But anyway, we have. Yeah, that's true. I wrote in here that we have a start, middle, and end to every problem.
Yeah.
Right? And then the start is where we try to get the ideas, right? We try to like have a structured way which we can actually tackle the problem. The middle is gonna be where we like work out the details, right? And then the end is gonna be where we have to like chain all of those details together to give us a result. Usually hard problems have all these three parts. In school maths, like let's just say, pretty sure everyone has the same experience of school maths anyway. The start is non-existent, right?
Yes.
Yeah. You just see it and you do it, and then like the middle and the end are basically the same as well, right?
Yeah, they are literally the same.
Yeah, they are literally the same, and you just apply what you already know to it.
Yeah.
And that's what makes Olympiad problems hard. You have a really difficult start, right? So like usually the hardest Olympiad problems, the ones that I see and the ones with the lowest solve rates have extremely difficult to find starts. And also some of it is just because they're in time condition. Like if you only have 4.5 hours and then you spend 3.5 hours solving problem 1 and 2, you're not gonna be that happy with problem 3, right?
Yeah.
Like so one thing is time condition, and second thing is Olympiad has really difficult starts. Of course, there are still Olympiad problems with like really difficult middle and ends, right? Like perhaps a problem with like lots of case bashes, lots of work to go through.
Yeah.
But yeah, um, okay. So problems with extremely difficult starts, uh, like there's the legend of the magic problems in Olympiad. Not sure if you guys have heard of it. Yeah, no, there are. I gave 2 magic problems in there. You guys can try them later.
Magic problem.
In the end, you guys can try them. But the thing is, magic problems have exceptionally unintuitive starts. Like, let's say if you have a problem and the progress is intuitive, each step leads to the next step, leads to the next step. That's like a very smooth, very classical problem solving, right? But like you can also have problems with like extremely like unintuitive, no idea what to do at the start, right? That's what I would call magic problems. Yeah. Another part is usually in the middle, right? So this is to give you guys some good intuition. You will try to figure out the lemmas that you have to use to solve the problem, or like key claims, right? Like for example, when we wrote up the proof to LTE, we had like what 1 to 2 lemmas per theorem. But the main lemmas come from the middle, where it like actually helped us, and then the end. This can be something like induction, right?
Yeah.
Like when you have a bunch of lemmas and then you can just induct it straight away. This can be like the end is like basically a way of like structuring everything so you get a result that you want, right? Yeah. Um. Yeah. So that's the start, middle, and end of a problem. Like okay, and then I want to go through some problem-solving strategies, right? So if we have a start, middle, and end, perhaps like how could we find a start efficiently? Or perhaps how could we find a start consistently, right? We want to get a start. Okay, so like most times, when you do problems for fun, you go through it step by step, and then until you get stuck, right? That's pretty normal, I assume.
Yeah.
But like when you get stuck, the problem gets hard. So like you want a way to be able to like go from where you get stuck and then have a good mentality still. Like mentality is obviously very important, but you have to have a good mentality to still proceed with the problem. So here I listed 2 strategies. One of them is called try everything you can. Also pro strat. This is a pro strat. Like if you're pro enough and you do this, you can solve anything. So like this is an old strat and a pro strat. So when you get stuck, try to see like what things have I tried already. This is why it's good to have rough work, right? If you have rough work, then you already know what you tried already. And then you can also have like some previous progress, right? So you can like jump from anywhere of your thought process to the next bit, right? So this is the pro strat. You try everything you can. But recently, I've been getting into a new kind of idea, which is roadmap. As I said, with information, you only have You only have a few pieces of information you're gonna have to use. And in Olympiad maths, like everything is technically elementary. Does that make sense? Because
Yeah.
what we learn in Olympiad maths and what we use in Olympiad maths is all technically elementary maths. Doesn't mean elementary school, but I think elementary school is what you understand.
That's sad.
Okay, wait. Will Chia was in elementary when he went into senior camp, so you know.
Yeah.
Yeah.
But he's William Cheers.
Yeah, he's also William Chia. Yeah. All right. So like elementary ideas. There are not that many elementary ideas, to be honest. Like you can compare sizes, you can compare modulos, you can compare like range domain, you can have like 3 points that line up. These are pretty elementary. But road mapping is you look at like information. Like if you have this is a question statement here. The question statement gives you like conditions, right? And you look at the conditions and see how can I use them later in my proof and how many conditions is sufficient to prove the theorem, right? And then once you have that, yeah, you need to apply it. And so this gives you an idea of the solution already. So like whenever you get stuck, just remember you can like always try things. You can if you haven't tried everything you can, then if you then you try everything you can. If you tried everything you can and you still can't solve the problem, it's because you're just bad, I guess. But yeah, just you probably need more knowledge and more skill to build over time. And road mapping is like a really good way to get to like a start, to be able to see like what kind of conditions do I need and what kind of a start would I want to get, right?
Yeah.
Yeah. All right, guys. Let's try the second problem in the problem solving tips.
Oh yeah. In the 6 problems, I think you made a typo in problem 6.
Wait, how do I make a typo?
You wrote let A, B, C be distinct real integers.
Oops.
Real integers. Such that for any positive integer I, AI minus BI is an integer. Prove that A and B are integers.
Yeah. Anyway, yeah, that's real number. That's real number. Yeah.
Wait, so I just solved it.
Wow, that's crazy.
I'm so glad I solved problem 6.
Okay, yeah, guys, try where is it? Try problem 2 in practice makes perfect. Remember, practice makes perfect.
It's like in problem solving tips. Imagine looking at the white unit squares. Like, we have a given text or a unit, we can select any ends and n squares and then use square and change the white cells to black. Black cells to white. Proof that after 2023 units there will be at least n squared black cells.
Yeah. Does that make sense? What?
Wait, can't you just keep changing the same square back and forth again?
Yeah, you can. That's how you achieve the minimum, right? But like, you can also like move it, right?
But that wouldn't. Oh yeah, that would.
Yeah. Oh, this was a senior camp problem, so maybe. I'll give you guys a hint after like let's say 4 minutes, because yeah, again, the difficult part about this problem is the start. Oh, ECMO is participating tomorrow. Wait, not tomorrow.
Wait.
In a week.
What ECMO is participating in?
Yeah, ECMO team.
That makes sense.
Huh?
It makes sense that the team for ECMO is participating in ECMO.
Yeah.
She doesn't like David. From the person. Yeah. That's what should we do is
Oh, ECMO is tomorrow. Wow. Oh. Oh, they're talking about. Okay, do you guys want a hint to the problem?
Like at least you just have to prove that there's always n squared whenever that you get n squared whenever you
Yeah.
prove that.
Like, one thing that you should be able to see immediately is that because you can move anywhere, like the structure, the kind of shape you're gonna get after like 5 to 6 moves is gonna look really random, right?
Yeah.
If you just like pack the squares close to each other, but not close enough that they overlap always.
Yeah.
Yeah. So like we can't really track that. Like we can't really track what the shape looks like. So we have to track something else. I mean, unless you're like a robot, unless you're AI, you can probably track the shape. But you can't track the shape. Okay, wait. I'll give you a another related problem. How would you solve this in one dimension? Like on a straight line. Let's say each time you have an infinite line of like white squares, and each time you like turn n consecutive ones of them on, and then n consecutive. You switch the position of n consecutive ones of them. Right? Try that. Oh yeah, also that's a good tip. Whenever you want to do things on like 2 to 3 dimensions, probably dumb it down to 1 dimension. Did you get the base case? I mean, not base case, 1 dimension. Wait, do you have the base case?
Why? What do you do?
base case, for example, you can imagine each time you, like base case in one dimension, you can let n equal to 1 or 2.
Yeah.
N equal to 1 makes sense, right? Because you're just clicking one thing at once. But what about n equal to 2, right? Also, you can consider the base case as like a line of integers. And each time you turn like n consecutive ones on.
The n equal to 2 case makes sense.
Oh wait, why?
Because they just either what you do. You don't just go completely cover it. You don't completely cover it on God move. You just none.
Yeah.
Then you just will happen. They just move apart so you can never cover more than half of the black squares at the same time. On the white highlight.
So what if you go like this, right? You do first move here, and then you do second move here. Then you get this, right?
Yeah. And then the next move you can't cover more than you can't cover both. You can only cover one.
But then you can move it back as well.
Yeah. So you can either go back into the medium or just move it further away.
Okay, I guess I'll give a hint here. Is that in n consecutive integer, each one of them leaves a distinct modulo mod n.
Oh, wait, so much for it.
Huh? What? Okay. Do I admit them?
Yeah, you can admit them.
Alright. Cool. Anyway, so n consecutive integers each leave a different remainder mod n, right? Oh, they're in here now. Huh? Yeah, so black square. Did you try the problem? Okay, you try the problem. Try the one-dimensional version. Okay. We're playing How do you have so many? It's the same game. They're all the same game. Cap them out. Wait, you guys still play Brawl Stars? That's like a 3-year ago thing. No. Oh, thank God. Wait, Flash.
Brawl Stars is good. It's the second best Super game.
No, Brawl Stars is like 4 years old. I played it when I was.
Clash of Clans is like 10 years old.
In year 6.
Yeah, it's so old.
I played it in year 3.
My bad.
Dude, 7-year-old men play like any game.
Guys, try the second problem. Wait. Yeah, second one.
Which second problem?
In problem solving tips. Oh wait, I'll write the problem report as well.
This problem is racist.
Why?
Why do they start white?
That's unfortunate.
Why aren't any of them yellow?
Yeah. You can make some of them yellow.
Hey, baby,
Wait, does Justin know the problem?
Huh?
Does he know the problem?
I don't know. Wait, I mean,
I think you should send the
this
thing.
yeah. Oh, wait, I'm just writing on the board so you can. You hopefully you can read it.
What's your man doing? 50-year-old men play.
30-year-old men fight.
Whoa. Why is everything that comes out of your mouth something gay? The average kid. Yes.
The average Minecraft like is 20.
12.
No, it's actually like 20.
I think there are a bunch.
Nah.
That is
The average ranked player.
Also, where's the 25 or I don't know. Java. Oh, then there's more like 16. Mostly who play are like 12-year-olds who 16.
So like
Most people who
Yeah, like
play,
me. Like exactly.
most people who play over 18.
No, that is random high school. Middle school and high school.
External moderators to make a living off block game.
Small minority.
They're not the small minority.
Most people like children hopping on to like play with their friends.
Same with Rustin. Rustin's also 13-year-old. The in-game.
What?
Ray. Russ.
What's Russ?
Ray Shadowman. Yeah, like 30-year-old man. He's going to attack the 30-year-old man.
oh no. Genshin Impact's just half my school.
Dude, like teachers to do Genshin Impact.
Dude,
He used to spend.
Dude.
Dude, he used to spend money on it.
I thought that was
That's actually sad.
I just spend money on
Minecraft. That is.
like game.
Anyway, the problem is on the board. If you could read it,
I don't know
I think it's readable.
You should like beg him. I think the money like.
Guys, we have
And then
problems to solve.
I try to beg and be
Yeah.
So like, kind of
I agree. What was that?
you're right.
It's either 20-year-old sweats or kids trying to have fun while being ruined by it.
You're all
I think you should make it bigger. Or just send the files into the Zoom chat.
I don't.
Send the files to Michael and then download the files on this computer and then send it.
Yeah, I don't think I could look at his stuff. That's not good.
You can close your eyes. Or I can do
Just ask him.
How?
Just say, can you see the question?
Oh no, I thought you meant ask Michael. So, yeah. I'll ask in chat.
Right. Say.
He already answered.
I can sort of see. Oh wow, he's. Which part can you not see? Can you just tell me that? I'll probably write. Wait, I can.
Does it say n squared?
Yes.
Yeah, wait, n squared, and so that's
Yeah.
wait.
The handwriting.
Okay, thanks.
My handwriting's readable, right?
Yeah.
Yeah.
Legible.
Yeah. When I wrote my English essays in HSC, I had way worse handwriting. Yeah, as long as they can as long as they can read it, they won't reduce marks. So
But like, it will make the impression of you worse. And then
yeah, it will.
They'll subconsciously feel almost.
Yeah, it's fine, because I still got alright. That's okay. As long as I got alright. Well, which year are you guys in? 9. 7. What school?
Most of the boys.
Yeah?
Random school, like a block away from it.
Oh, I see.
What school did you go to?
Clara High. It's one of the schools.
I mean, my school,
One of the
this
schools
place
ever.
50th in HSC last year.
My school
That's
was,
decent for a non-selective school.
That is.
wait, my school was like 60th or 70th or 80th. I forgot something. Yeah.
My school was
And red. Not even best practice.
I did red and
They call it.
so.
I got solved the problem.
Red.
Oh yeah, wait, tip. Alright, tip. Reduce to 1D first. 1 dimension.
And also Leo.
What?
Are you sad?
No. Oh my god. Could you see the tip? So reduce to 1 dimension and use modulus. I hope you can see it. Anyway, guys, that's the tip. You try to reduce it in 1 dimension first and see if you can generalize. Oh, wait, also, there are way more other problems to try. Wait, I'll write some of them on the board. Another problem.
Cap.
European
don't need to tell me.
Have you spent money on the game?
I have not spent money on a single one. What sense?
Have you?
Not even for a birthday.
I'm not gonna. I know you.
I had.
I've only spent like $20.
Oh, my
Begging.
I'm begging factorization.
Imagine unranked.
Alright.
No safe typing. Yeah, only the 800 pounds.
Yeah. Only everyone.
I kind of got bored.
You wasted money on the VIP. You could have bought me VIP instead.
Imagine having VIP.
I still sometimes hop on and play a little bit of Sky.
Yes,
And
Skype.
a third.
The travel is so bright.
So yeah, try any problem in the board. These are from my handouts.
1 million.
I have 2 millions, and one of them,
I have
my
7.
friend gave. One of them is the cobblestone.
And -1 factorial
And
plus
the other
1.
one is like individual.
One of my friends gave me a tier 12 snow minion. Yeah.
Yeah.
One of my friends gave me a stick.
Tier 12 is a high.
Over the infinite. The infinite. Because like 1.5.
Imagine, why would you buy VIP though? It's honestly
VIP is bad,
useless.
but VIP plus is more worth it.
MVP plus.
MVP plus is the
Why
most worth
pixel?
it.
I have a
Why
big
Oh wait, he doesn't know their LP.
And I feel like
If you don't know Lifting the Exponent Lemma, oh wait, just search it up, Google it. There's probably like some videos.
Wait, are there any 3-letter names that haven't been taken?
Yeah.
Like,
Oh, no, not being taken. No,
I had to smite mine.
every single one is being taken.
I just put with random letters.
This is
The
all
first 3 letters.
finite.
Yeah.
So all are being taken.
You need the Lifting the Exponent Lemma for the
Wait,
last
what
2
number
questions.
do you
For the
think?
first one, it's a combi problem.
There's,
But there's still all of them being taken.
36 times 36 times 36 times 4.
136 and 36 and 36. 1 and 36. Also do special characters.
Guys, what if we play a fun game on an infinite grid of squares?
There has to be one, right? We can't have like tried all of
Yes, they have.
them.
I mean, my friend has a full character name. That's all I know. I have like 7. So I have a 6 character name on 10. Which is built different.
I have a name.
You do?
In a few hundred years, I won't be able to make it. It's MVP plus cost like $80.
Only at one time, my friend spent $800 on Clash Royale.
Just about to get mad.
Yes. When they found out. When they like banked somewhere like the one came back. I said, imagine if you spend your money on them, it's like the top one gave me $800.
Oh.
And then, how did they?
You should have done like small countries.
He did. Across the month. Oh, $50 here, $50 there. And then eventually $800. It's like a brand new coin. But then his parents, so they come up and suit himself and self-employed, he had negative 50k gems. And like negative 100k gold. But if he's playing and ends up 3 tournaments, you have to have at least 0 gems to participate.
Wait, so did the money game?
Yeah, so the money got refunded from most like half his legendaries. Even the ones who got legit. It's like he did spend some money before what that was allowed. But then they refunded everything.
They should have deleted their account.
No, because he can still fly with a negative 3. And if he managed to get all his gold back, had positive amount of gold, but not gem. It's like really impossible to get.
Yeah.
Why did he buy it?
Can he still use gems?
No. Like he kind of ends up with or anything like challenges.
It's kind of hard to say.
50k gems.
Just buy it again, ask your parents.
So $800 again, yeah.
Yeah.
Oh, I'm gonna $800 to get my gems back. Yo, I know he just turns me after like 3 days. Oh, I've had enough of Flash Royale, I've given up. I'm just too good for the game. Yeah, and then he moved to Brawl Stars. I got sadly he hasn't spent that much money on Brawl Stars.
That why you spend any?
I have like 500 and then
I
8.
like 3 on my phone. No.
And I had 500. Do you have 4? Yeah, that's like 500 isn't it? 3k. Oh. Oh, then I have.
Oh, if they changed it, you don't unlock all the trophy rating more. It's so dumb. That's why I stopped playing.
Oh, I just stopped playing because my parents don't listen to my
I
iPad.
stopped playing because the updates are weird. It's unrecognizable.
Patreon is garbage.
Patreon was 2016.
Dude, it was good in 2018.
It's good in 2016.
It was good in 2020.
Like, I mostly played in
It was
2017.
good last year.
You guys started soon, like 2016.
2016.
Yeah, I was really bad. I lost like everything.
But you guys were in year 1.
Me?
Year 2.
My brother got to Frozen Peak. My brother got to Frozen Peak, and I played on the account, and then I dropped down.
Wow.
You can do that, and you used to be able to
drop arena.
That's why it was like, you also have.
Wait, you can't drop arenas now?
You can't. That's a lot.
Wow.
Yeah, no, people full legendary deck in Arena 1, you know? And then it got so popular that they'll just be versing each other. Full legendary deck versus full legendary deck in Arena 1. How do you lose that really quickly? I'll try to just open a game and try to anything. It takes so long. Yeah, if you have already.
People have too much time.
No, they only need to, all they need to do is press one button. Like every 2 minutes. Even that is like 3,000.
Every like 10 minutes, they like go. It's only taking like 5 minutes to get to 3 crowns. So playing like conservative long base. Oh yeah, long. Oh when I was gonna change so long, I was gonna play long base.
DPS.
Like this is
All they need to do is have a tank and like something with a lot of DPS.
Inferno Dragon and Mega Nut.
Oh wait, yeah, trust.
Are you messaging Michael?
I don't know.
I remember when they were started. Oh, no.
I remember when Knights.
Yeah, I don't remember when they were. Well, I remember I started playing in 2018, and then I lost my account. I mean, the account's still there. I just don't remember the 2016.
You used to be able to get 3 legendaries in Arena 6. That was actually pretty recent.
Oh wait, you were in kindergarten in 2016.
Oh.
Wait, in 2016, what was I in 2016?
You were in year 2.
Yeah, I was year 2 in 2016. And then now, like, I spent like 6 months grinding into this, and now 6 months grinding. And now I spent 5 minutes playing, and I got like a Pokemon that was better than my 6 months of grinding. Not even fair. Also, I got the accounts lower than mine, which is like. Okay, I think I solved it.
What?
I stopped playing Pokemon. And easy, and also I dropped a bunch.
Have you solved it presented?
I think it's yes. Why were you playing Clash Royale when you were 2?
I wasn't 2, I was exaggerating. I was like 7.
Why were you playing? Oh, you started playing in 2018. And I immediately got to Challenger 1 and then I lost my account.
How?
Because he's.
When I was 6, I took it against like Barbarian Bolt.
I was Barbarian Bolt.
Right.
Yeah.
I'm going to reteach LTE to Justin because I've been.
That'll probably take like 5 minutes.
Wait, does Justin like do well?
I think
he's
in
year
10.
Oh.
Year 10.
Year 10. Okay. Wait.
Oh, he's only a year older than me.
I'll prove LTE then.
Okay. I don't even know how to do.
Yeah, Justin's actually intelligent.
Guys, move on to actual games other than Clash Royale. Move on.
Why? It's actually fun. Okay, we'll move on.
Nostalgia.
To my friend. Let's talk about Tetris.
Tetris is a good
Okay.
I'm so good at Tetris.
Oh, I'm so crappy at Tetris. What's your rank?
What's the last rank? No, like seriously, I'm in the bottom 0.05% below. On the bottom.
Is that good or bad?
The worst
I'm in like the top 20%.
Well, have you ever played on Tetris.com?
Wait, no, I'm only moved up to the bottom 0.1%.
J-Strips.
Oh
I
yeah.
have played on that. I've wrecked my friend. It was so funny.
Wait, what's your rank on Tetris?
Never played on Tetris.
I've
I've only done on Tetris.com. I got my highest score 200. Tetris.com? Yeah.
Like Tetris.
Isn't that like an ad? No, it's an actual website. You can actually play Tetris on there.
I'm sorry.
Okay, hi Justin, I'll be teaching
What is
LTE
it?
again.
Spin the T while you're getting it in.
So basically,
Let me find a pen.
create a hole. And you put the T in the hole and spin it.
That's so.
Like this. Imagine this was a hole and this was the
Also for my handouts,
The bottom is 0.1%. Why?
That's fine.
if you could have somewhere where I can send it to, that'd be great. Are you in like any
Yeah.
like Discord chats?
I can switch tabs.
You're probably in solid Discord chats, right? I'll send the files. I'll send the.
Yeah, maybe I should go.
Okay, cool. I'll send the handouts to you.
You can't get it out. Wait, no, don't help him, don't help him. Let him get it. Have it stuck in it. Okay, let's do the problems now.
Yeah, you guys should do the problems.
Let's try number A. Number A. Still quick problem.
Oh, I remember for problem 6 it says real numbers, not real integers. Yeah.
Can we interpret it as real integer?
No, you can't.
Oh, can we start with a C?
Okay.
Liam, does the name start with a C?
No, it doesn't.
It does start with a C.
Is the second letter an H?
It does. Yes,
No.
that is correct. The third letter is an A.
Alright, I'll send it to you on
Is
Discord.
the
Yeah.
fourth letter an R? L? An L? And then an O? Why are you getting so red? And then a T? And then another T? Why are you blushing? And then an E?
And then an S.
This is false
And
news.
then a U. And then an N.
False news. False news. There's no one named that. Oh, shit, you okay?
Wait, is it double L?
Oh, he's not okay.
Oh, I sent it to you on Discord.
He's contacts right now.
Wait, you can see it through
He's messaging his contact.
what reflection of the.
Oh! You can't read it though. Oh, what is
I guess
it?
I'll be mainly going through LTE. And then for problem solving tips, there are like generally tips that I found really useful, especially now when I try to solve like difficult and more generally just any problems. So, but also problem solving is very individual. So like read it and then you don't have to implement it, but just like give them a thought. That'd be good. Alright, we'll go to LTE.
No, what?
So
No comment.
yeah, we'll revise factorization first.
No comment.
Why are you blushing?
Get a lot.
Oh wait, we'll do this first.
Stop trying to throw a ball at me.
Stop touching balls.
How much your ball?
Is that a success?
Is that actually bad?
Anyway, we know this is true, right? And also, wait, another factorization.
I'll touch your balls, Jasper. And I'll steam fry them.
Ah!
You know, killed Lachlan.
My bad. Wrong person. I'm bad at it. I missed.
I'm bad at it. Your mum's bad at it.
Spicy.
So,
Sit down and breathe.
these two are the primary factorizations you basically need to prove the LTE lemma. What lifting the exponent does is it basically allows you to calculate like the maximum number of power of a prime that divides like a particular difference or sum of like two powers, right?
When you still
Yeah, it's useful to just apply it whenever you see it, I guess.
And then we wait for notifications for the proof.
Yeah, okay.
What is this?
Me waiting for you to bust the phone again.
What the hell? You guys are all like the most desperate.
Oh, can you see the theorems in the handout I sent you?
Yeah, I
Just-
got them. Yeah.
Alright, cool.
I will touch you.
You are already.
You're bad.
So I think it's important to just remember the main idea to proving these theorems. So even in contest conditions, you can just reprove them if you forgot, which I did. But so the basic idea is once after you factorize it, like let's say once you factorize an minus 2n, you get
Why?
Lachlan, take a
going to have no part in this array?
You want to analyze like the
What was
basically the number of prime divisors of each one.
Right.
No, not prime divisors. The number of times a prime divides each one. So we can write this as like
what was the name?
VP.
It wasn't possible. It was possible.
It was my glasses. Stop. This is like.
Oh,
It wasn't possible, right?
yes.
Oh my god.
That's all the same.
And the thing is, the key claims here is that we can calculate exactly what this is when we just take. Oh wait, I'll circle it.
Guys, calm down.
We can calculate exactly what this is when we take modulo p and modulo p squared, generally for odd primes. And for p equal to 2, it's a special case, but it just takes a little bit more work, and it's the same thing basically. We'll write out what it is. So VP.
Why are you contacting Theorem? If any better.
Like what?
Instant messenger.
Is equal
Discord?
Like,
It's because once a relationship gets serious, they start using messages. Like
Bro, shut up.
before, like they use Discord, but then after they start using messages.
No.
Prove me wrong.
That's not the case.
Alright, well, we'll also say.
So you're gonna say it's not serious?
Oh wait, okay. So we have
Yeah?
we have this is
Oh, yeah.
Show me the messages.
He said it's not serious. Yeah.
Yeah, I said that. Yeah, it's
Right.
not serious. Not yet.
It's gonna get
N
serious.
equal to
Did you
P.
hear what he said?
equal to 1.
Bro, I'm going to get serious about.
Alright.
Prove.
You guys are solving problems?
Huh?
Not.
Yeah, guys, do problems.
These three and
Wait, we
solving problems are mutually
Wait,
exclusive.
Problem.
So the plan is, someone holds it back, someone takes it, and then two people hold it back.
Okay,
One person ID.
What the heck?
This is what you get after calculations. Does this make sense? I'll calculate them so you can also see it as well.
Just hold it up away.
Does it make sense?
Yeah.
It's
Cool.
Liam.
Limbs.
Oh, Liam.
What did you think?
It's Liam. Holding his limb.
So like, I'll do his right limbs, you do his left limbs, and then so right then
You
takes
do it. Organized crime.
Get his arm away.
What the hell is this?
What?
They're having a consort. Big M at the steel pipe. You're a bad boy, Jasper.
Okay, so we'll have claim 1 and claim 2.
Hold his back.
Claim 1.
What is your...
Help me.
Yeah.
Oh, peasants.
Give me my phone! Oh my
I'll hold him
god!
back. You do what I need. I'll hold him back. You do
Hey,
it.
calm down.
I'll
Give
do
me
it.
my phone!
Use Face ID.
This is
What
we'll
the
calculate
hell?
this. Also, I forgot to mention the condition that A and B individually are coprime to P, but A plus B, P divides A plus B.
Wait, how do I face it?
Wait, P divides A minus B, sorry, not A plus B. So P divides A minus B, but A, B.
Your password is required.
We still have a fun.
Dang it.
No!
No, we wait for the notification to come up.
Yeah.
There's already 2 missed notifications.
Oh my god.
To calculate this, to calculate this, we just modulate P. Mod P So this condition gives you a.
I thought he was using.
Stop that shit.
Hey. How does it actually stop?
Small child. Not even a year 9. Just a fake year 9. Small child.
The years face it out.
But does these lines make sense? You can type in chat or just tell me.
Yeah. I think.
He's a pet.
And yeah. Now we have that B and P are coprime. B, P coprime.
What's
He
it?
likes this.
Are we making a burger?
Oh yeah. Yeah, yeah. Burgers with Michael. Oh yeah, burgers without Michael. Sorry.
Yeah. And then yeah, these make sense as well. Yeah. Okay. I'll rub out and we'll work out the second part. So this is the case if N and P are coprime. Now, if the maximum power of P that divides N is K, then this is actually equal to K, and that can be proven with induction. I'll show you.
How do you have enough strength? I'm so heavy.
Stop mucking around.
How did you have enough strength to pull me to the ground?
You just are desperate, Jasper. Incredibly desperate.
And actually, it's
Let me grab my paper. I'm gonna check my feet.
how did you pull it down?
These are probably worth more than you.
65, I'm like 35. That's like 45. It's like 60. That is 60. 85.
80.
Oh,
Yep.
I mean, you just need 2 more people.
Us weight. Our combined weight is less than 50.
What?
Wait,
55 plus 40 plus 35?
No,
like-
me and him.
Oh, yeah.
45 plus 35, that's 80. Actually, I think I decreased my weight, so I'm like 40.
Oh.
What is this? Benching.
Oh, yeah, I can bench them.
How much do you weigh?
Midgets harassing me.
Wait, you're 35, right?
Again, we use the fact that we have
You
P
go to the
divides
gym.
A minus B,
Sometimes. I don't remember.
so
you're
A
short
modularly
bench.
equal to negative B.
Oh, yeah, let's get an upper two. Okay, this could end poorly.
So the key thing to note here is that instead of just modular P, because we want to say that it's exactly equal to 1, right? Instead of just modular P, we modulate it by
It's not going well.
P squared as well. So we need to prove that it's 0 mod P and it's like not 0 mod P squared in order to get the result that we want.
You can't be crazy.
Okay. And then
I can't be what?
You can't be her hate.
by using the calculation
You know
before,
that.
we know that
Boy,
summation
people from
I
my
equals
school.
0
No,
P minus
you know
1
Anthony
A.
Ivanov?
Yes.
Yes. Yes, I do know him.
I've seen him.
Oh, yeah, you know him. He's also Russian, like.
Yeah, I know.
And then this will be equal to modular P times
Does he
by.
have a sister?
No, that I know of.
Okay. It's not that, does it?
Basically, wait, Anthony.
Wait,
How
this
to get
is
girls? Call them for 3 days.
this is true because we just calculated. Yes.
No, you should test it out.
And then
So ignore her for 3 days and see
so-
what happens.
your division P divides P divides.
After 3 days.
He's
Now-
too desperate.
It could be.
He's too desperate.
We're applying into your bum.
Wait, now that he's up to he makes me sick.
Yes, and all. Yeah.
Oh, my bad.
Sorry, don't
So don't open it as otherwise the basic might.
Next time? So there's gonna be a next time?
Maybe. Not now.
But what would happen if she came in the holiday?
Yeah, so we write it as kp plus b for some
It
integer
would be a
k.
lot of shit.
And then what we do here is binomial expansion. And then we get...
Oh wait, let me see. Is it still there? Wait, Lachlan, open that door.
Oh, actually we don't binomial
Why
expand,
didn't you?
because what we do is we just look at
There's
this.
something in that room.
We know that,
And look at that. For one of the whiteboards. Like, is it?
You're gonna trap me inside.
No, it's not that. I promise I won't.
You're the big. You're the big.
Supposedly this is a work of art.
Wait, who made this?
you okay?
Just
Well, he's smart.
Okay.
He knew it.
Right from the start.
I mean, I kind of
There's
predicted
even
it.
mic shift to intro.
That's true because we just wait. No, sorry, not the mic.
how did you
Minus.
predict it?
I just thought to myself.
Well,
We can just write.
Well, what?
I'm a very observant person.
Michael was shifting.
Well, yeah, Michael was doing that. What did you observe?
I forgot. I was like, trying to get. I just remember
Yeah,
thinking
you two,
it's gonna be.
you two were talking about some like political
Oh yeah.
problems and about gender equality.
Anyway, so because this is equal to that, we just take VP notation of it, and then also it's equal to minus,
I'll leave
right?
you hanging off the back.
And then we'll just calculate what this equal to.
I'll leave you hanging on a
You can calculate what this equal to using binomial expansion. We'll do it here.
I'll leave you dead.
Oh, that's the worst. I'll leave you on the line.
I'll leave you
I'll
in
leave you
Lachlan.
decapitated.
Wait,
I'll leave you on the
I'll leave that
Oh, yeah.
decapitated in some.
I'll decapitate you in someone.
I don't know where this is going. I'm confused. How do you
I'll decapitate someone in you.
I'm just kidding. Why is everything you say so anyway?
I'll decapitate you and start in the decapitate Slaven you.
How does that work?
So basically, Slaven decapitate, then he goes inside Slaven, decapitate.
I will decapitate you.
But that is very gay.
You're
realize-
very gay.
Do you realize? I think he has bipolar disorder.
I do.
Half the time he's very gay, and then half the time
It's
he's
quick reply.
yeah, exactly. He's that guy.
Okay. And then
He's that guy.
Bro,
so we can take away
you're not a guy.
Oh.
when I is greater than equal to 2 because we're mod p squared.
Liam, this is you.
Yes, this is true.
This is his mom.
So after we take away all I greater equal to 2, we get is
Wrong
this.
That's your mom. And now you're inside.
Bro, I'll be beside your mum. You three are not conducive to solving problems. Especially you, Jasper, and you.
We probably miscalculated somehow when we correct this.
I solved question 2.
What?
How?
No, you didn't.
When do you have time to solve question 2?
Bert is using the epic defense
The what?
of his legs.
Indeed.
So very bad.
But oh my god.
Bert,
You can't.
you actually have bipolar disorder.
Oh no, it's called the.
I think I miscalculated somewhere along this line. Let me try to find it.
Don't even think. I should also lunchtime.
Do you think this kid has ever talked to a girl?
Yes, his mom.
Yeah. I have in fact.
It's not your mum.
I talked to many.
Alright,
His
has the girl
teacher.
ever talked to you who's
Yes.
not your mum, who's not your teacher, who's not your age by choice?
Yeah.
I was like younger, like. But what do you mean by choice?
Like, they were not forced to through school or anything.
Yeah. What has happened?
Really?
Multiple
Yeah,
times.
same. Yeah.
Yeah, multiple times.
I think I missed
Yeah.
that.
Yeah.
Yeah, what did they say? Please don't
Oh, no,
ever
yeah, it was
talk
like
to
2
me.
years ago.
Oh, what did they say to
I
you?
don't even know what they look like or where they live or anything.
Actually, we'll just use binomial expansion, but there's quite a lot of ways you can prove this because it's just factorizing and then calculating the powers of the nine.
Ego.
Your ego.
Yeah, like in real life. They said it.
I'm gonna look up a proof because I forgot about that.
Okay, and so no.
You don't want to pop the ball, Liam?
I'd like to see you try it.
I would not like to see you.
吃吧，好吗？
Yeah, I would not like to see you try it.
Oh,
Not sorry.
Thanks. I can only have 2 items here. Be careful, I'm going to add some. Potato, pasta.
Oh, they're really good. Yeah. So to prove this, you just do binomial expansion. Actually,
Why would there be chicken in the bread?
I'll bash it out, but I believe you can do it yourself as well. I'll bash it out.
You haven't said something smart ever. So. What's the smartest thing you've ever said?
Bomb.
I feel like out of you three, Lachlan would be the most likely victim.
I agree.
What? How about I did up for
Lachlan.
I agree.
And the least likely would be Jasper.
I don't agree.
why don't you agree? Wait,
What
does
do I
this have chicken on it?
What?
Wait, it doesn't matter because you can't eat eggs, right? Yes. So if I the chicken one on egg, I can't eat chicken because I can't eat egg. Or the other that makes one of
And then we basically don't care about anything for
yeah.
I greater or equal to 2. Because when I is greater or equal to 2, it's modular equal to 0, right? Because we're modding 2 squared.
Nice. I can't have egg because I can't have chicken. So you, I think that's like, I don't know, one of them. I think you can't have chicken because you can't have egg. No, but I can't have egg because I can't have chicken.
Someone tell me that there is lunch.
Huh?
There is in fact lunch.
Oh, thanks, guys.
He didn't cook it.
Actually, the variables on the left is actually also on the left.
Did you know that they're trying to make weed legal in Australia? Yeah, yes, okay.
And then, okay,
Do you like weed?
Yeah, pretty enjoyable.
Lachlan, what's your opinion on weed?
It's really profitable.
You know that they're planning to make it legal in Australia.
That's a good idea.
No, but that's profitable.
Yeah.
That's what they're trying to make. They're trying to get rid of drug dealers.
and then we'll calculate.
illegal drug dealers. By allowing drugs. Yeah, you're getting
Go back
rid
to
of
calculating the sum. This would be
Is out. Oh, did you know that I can make any country's crime rate 0?
Exactly. Right.
Yeah, just get rid of the
Sign the
laws.
pledge.
Let's get rid of the laws. No laws, can't break them. If you can't break the
I know how to
laws,
make every country's crime rate, poverty rate, disease rate, everything 0.
kill
Kill
them.
everyone.
Nuclear bomb.
It would also be quite amusing to do that, wouldn't it?
I think that's what Putin thinks.
Oh yeah, what's your opinion on Putin?
Oh, he's very bad.
Oh,
That one time he took my candy. Not about that slide.
Oh, yeah, later
We
on.
don't actually have any supporters.
Yes.
this kid.
He has a bunch of supporters. Does he give children candy? Yeah, he took my candy and he gave it to his supporters.
Oh, so
I think
then-
all borders have been random.
I think they all want candy. Oh, everyone's just being fucking.
Oh, do you have family in Russia?
Yes.
Oh, what's happening to your family in Russia?
Oh, they're sitting on a chair. Oh no, they're actually sleeping right now. Are they in the Asia side or in the Asia side?
Oh,
Except for like one who's in Europe side. Like on the border. Like, in Moscow.
oh,
That seems safe. That seems very safe, yeah. Who's that one family member? It's my aunt that she's going to university. Then she's probably better than math. Then better than math?
What percent of the Russian civilians?
No idea. Are you playing tic-tac-toe?
How is Putin even in office?
I don't think he is. Yeah, it's just a bunch of crimes at this point. AI. We only have like 17
you actually
different
really suck, man.
It looks like a man.
Anyway, I think I probably miscalculated again, but it eventually works out.
You just ruined my appetite. What is? Oh, I remember you just ruined my appetite. Why? What did he say? What did you say, Liam?
Putin sucks.
Oh, I didn't miscalculate. It's great.
Oh my god.
We get here in the end.
Putin sucks.
Yeah, and that's not good.
Actually, it's so big
Because
it goes
that's
all the way
not-
to Russia.
Because we're modular p squared, right?
Bro, your no one's father, no one rashes.
Does that make sense? I hope it makes sense. Hello?
Oh, me too. Yeah.
Yeah, it's calculate after I miscalculated like twice.
It's not good.
But yeah, we got it.
Yeah, I did know that.
Yeah, I think you'll be able to.
Okay.
Don't worry about it. Now we'll erase
Yeah.
this. Where's the paper? Oh, here it is.
Look, take 3 steps back.
Why? Ooh, what's that image?
Image of your mum. What?
Okay, and then we induct, right? We induct this way.
What would happen if I take 3 steps back?
So we say
No, you can't. You shouldn't do it now. Not on the slide.
Slava.
Yeah.
well, I mean, I won't really induct it here, but you'll see how it works. It makes sense.
Wait. The clean cups are in there, right?
Oh, 7 out of 10.
These are okay times
So
like
it's
that.
very scammy.
Oh, remember when we found this cup in the green bag?
Come on.
It's okay. Nah, it's alright, I can stay.
Hey, Liam, take the cup. Liam, take the cup.
No, I
Why
don't
not?
trust you.
It's a
Well,
scam cup.
Hey, dude, I took a small one as well.
Whoever wants that.
I just have to say again. Okay, time wise. No, it's not. Wait, why is that?
No, I was not saying Uber Teddy. What do you think?
He means what he said.
This is what Jasper
How
probably said.
wise are
Who's
we?
horny at Jasper or Stefan?
What?
Who's the father?
Stephen.
Stefan.
Wait, what was the question?
Who has more horns?
Wait, P.
No, what was the actual question?
Which one?
Is what?
Who has more horns?
Second.
Sure.
Because, you know, stuff that wires me.
Oh yeah, yeah.
Who's
And then we know
Stefan?
this thing has exactly
Who's
P
Stefan?
divides this thing exactly once. P divides this.
What did Stefan do?
We got some fun videos of anime characters.
And then you can basically see that each time you're taking away one power of P and you're increasing the number of times P divided by exactly
I'm on
one.
it in my mind
right?
now.
Wait, does that make sense?
Yeah. Yeah.
And you can see also how you can just repeat this, and then eventually you just get this VP of
Or like you can delete the rest.
yeah, you can delete the rest of the powers of P, right? Like, look, here we deleted the powers of P
Yeah.
by one.
Yeah. Okay.
And then plus.
Yeah. Oh, so you can like iterate. Okay.
Oh wait, oops, we're on right
I'm
now.
in all.
You.
That's a thing.
It's because
I'm in all boys.
it's because
Yes, time.
only they split the class by languages, and only 10 girls out of the
Anyway,
40 girls.
This is true specifically for P being an odd prime.
Because I don't know.
But
because
for P being even. Oh wait, hello.
only 10 girls.
Wait, did you say something?
Latin?
So
We
Oh
are
no.
orange.
No.
put all of them in one class.
This is true for P being an for P being an odd prime. But for P being even, it's basically the same thing, but you just like do a little more calculation. So I have a few problems on handouts. You can try problems 4 and 1. Problem 4 is probably the easiest, and then try problem 1. Yeah, once you get the solution, just like type in chat or like tell me, and then explain it to me.
Okay.
Yeah. Grab
How
some
many
food.
languages does
Wait, I think you're muted.
So,
Oh yeah, 4. Yeah, okay, yeah, I was muted. You're right. 4 is only a equal to 1. You can do
Okay.
problem 1. Problem 1
Yeah.
and 3 are maybe similar. I'm not sure.
Okay.
I probably should have muted. I'll go on mute now.
So American Maths is ridiculously easy as well.
I mean, like all school math is hard.
Yeah. Still, NAPLAN is just sad. Like, NAPLAN Maths is...
dude, in year 7, I got band 9.
What's my name?
So, like,
What's
year
that?
9 level.
Oh.
In year 7.
Wait, that's decent. Is it?
Yeah, I only do so that's pretty years.
You get the triangle.
What triangle?
Why? You guys look at my HSC stuff?
No, I think that's
No,
10.
you're looking at
I was on the top. I was the one line to the triangle. I was pretty close to the triangle.
Yeah.
That's okay. You should be aiming for a triangle. But for some reason, I
I
just
didn't even know anything. I was just randomly. I was just doing maths, just answering questions.
They've made the NAPLAN all online now.
I didn't get the triangle for reading because I'm suck at English.
Dude, my spelling was 6.
Oh, I think I'm gonna get like banned. Really low.
I
Yeah.
don't know. My spelling was
Are you
9.
just trying to find all the
my writing
pictures of
was
you?
6. My spelling was like 9. Then
So
my
there's so
writing
many
is
pictures
6.
of me on
My
Twitter.
rating is
I mean,
7.
Did you only need the triangle?
Oh yeah.
Maths was the only one that was like close. Spelling was like in the middle of the 9, so the top one.
No, I don't think that's him.
That's
No.
Yeah, wait.
Such a.
What do you do for a living?
Yeah, I know. I do. This is me.
Wait, what uni are you going?
This is me.
I'm currently a USID.
What degree?
Maths, obviously.
Just math.
Yeah, wait,
What
what
were
do
the
you
requirements of the degree?
IMO Gold
98.5.
medal.
Oh, no, wait. No, to get into USID, it's pretty easy. You just, like, with a 92 ATAR, you can do any, like, science degree you want. But with 98.5, I don't know. Apparently it's different. It doesn't seem to be.
That's him.
Oh, okay.
Yeah. Oh, do you guys have bottles?
Who is 0450850712?
Cups. Yeah.
The
How did you get my wrong?
Wait, is that your mom?
the grey tub.
Wait, do I answer this random person?
Yes.
Oh, no, wait.
Go on, close it back.
Sure, I'm calling them back. Recent.
Why is it calling a random number that calls you? Here we have a year 9 who's shorter than a year 7.
That's normal.
That's not
Would you like any hints for any problems?
Shorter than a year 6.
I could give you some hints.
Are you the shortest guy in your group?
No.
Not like probably only 6, but I haven't really like done it properly. Yeah, I think I'm fine for the other ones though.
You're the
Yeah.
short.
You're fine for the all other questions except problem 6?
Yeah.
Oh, that's cool. Alright.
We have super short.
Yeah, problem 6 I miswrote. It's real numbers, not real integers, because what else makes no sense.
No.
Oh yeah. Okay.
Also, problem 2 I miswrote as well. It's supposed to be sum of whoops. I'll write it on the board. Oh my god.
Must be flat.
Yeah, bet.
Wait, if you're
Wait.
If it looks like I have the deck for that.
When is Michael coming back?
Chat using bubbles. New conversation appears floating icons of bubbles. Tap to open bubbles.
Stop looking at Apple update notes.
Okay. Liz calls to
Yes, fair. 5.
Liz call 3, 2, 1. You have 2 new voicemail messages.
Are you online? You're not online.
Wait, get the voice. Listen to the voicemail.
yeah, I miswrote
That's
it
me.
because in latex
Yeah.
I forgot K above, right? With like writing the power and stuff. I forgot to put the K above and now it's below. So it looks like it doesn't read any sense. So anyway, that's what the problem is supposed to be.
Oh, actually,
Yeah.
Oh wait, is that I spelled N or K?
That's a very good
So this is N. It's sum from I equal to 1 to K of I to
I have a very
It's like
yeah of I to the power of N. Yeah, sorry.
My will break it.
Okay, got it.
Yeah.
Oh, right, yeah. I forgot.
hurry up.
Wait, I'm trying to find the deck.
No, use your normal deck.
No, bro. I don't know if it's Mega Nut Cycle, bro.
Why would you
Oh,
play
yes.
Mega?
Yes.
My deck is Mega Knight with 1 elixir cards.
Oh, my deck is even better. Is he gonna be leaking like?
If you're in James, surely you've heard of how Sigil is like top 2 in Australia.
Yeah, I know you're just doing this.
Actually, no.
Bro, I know you're just doing.
Rocket cycle.
Yeah. What I'm doing.
Why am I running out of elixir?
Because that's how the game works.
Why am I running out of elixir in infinite elixir?
Because it's only 7 times. It's not actually infinite.
Oh my god.
You bro, you didn't even rocket the king tower. Tower down, tower down.
They have incredible concentration levels.
Yeah.
Dude, I don't think that's gonna save you.
Just have an incredible ability to distract everyone
This
else.
is not good.
Why does this work? Why does this work?
Get wrecked, bro. Get wrecked.
Alright, bust me and touchdown drop.
Wait. Oh well.
Even the actual skill one is triple drop.
No, touchdown drop is also very fun. Oh my god, no, can we restart? Please? I
Are
accidentally
you in the map camps? Training camps?
Oh my god, I accidentally pressed now have lightning.
Yeah.
Wait, what does he have?
He has earthquake.
Okay.
Wait, I got the best card. I got the best
Wait,
card.
I don't have any fast tower thing cards.
Yeah,
What do you mean fast slap?
slap and
I don't have any building target cards.
Yes, you do. You have Ram Rider.
Wait, oh, you gave me Ram Rider? Thanks.
Yes.
he got hog rider.
No, I got Royal Homes.
Wait, that's even better. What? That's not fair.
Please,
I
please.
don't think that Goblin Cage was the best play.
Yes, it was.
Oh, what a play. But they have archers.
No.
The singular archer.
The singular. What are you doing?
There's a ram right
Failure.
Not this again.
Why would you just earthquake nothing? Please.
Lightning is kind of important.
Dude, that singular archer. Survive.
Oh,
No, it didn't survive.
Well, play.
Dude, I'm dead.
Not gonna do anything.
Oh my god.
Oh! I'm so good at it.
My inverted tower is nice.
I know, that's the whole
You only
point.
have one building.
Yeah, you only get one building. Lava Hound!
What?
So
Good God, man. Good God.
Not gonna.
Why would you... Please tell
Oh,
me
I just
everyone
went target.
good and looks on.
Into lightning. Oh.
Okay, is it gonna kill the lava hound?
Oh. Oh.
No! Why would you kill my troops?
Uh-oh.
Those lava pops. Oh good, I thought I missed for a second. Oh my god.
Oh.
Please tell me that splashes on.
The bats.
Oh, that's fine.
That's not fine.
Yes, it's fine. If I say it's fine, it's fine. Please tell me that. Oh wait, yeah, I just won.
I missed! You have
38
one
seconds
button.
left.
Huh?
38 seconds
That's
left.
literally why I chose Royal Hobsborough. Don't you understand?
No, just don't defend, please.
What do you mean just don't defend?
I'm gonna. Please tell me I didn't miss. Very good.
Is that
Doesn't matter, we'll just kite them with the balcony. No shot.
Alright, triple drop me.
Triple drop, yeah, sure.
skillful game mode?
I'm just gonna pick all the
No,
legends.
mega drop. Mega drop is even more.
No, it takes too much time.
How does it take so much time?
It takes way too much time.
Where is my deck? When
You got challenged to a friendly battle, you're not accepting.
I just need to get my deck. So
You don't need a deck for triple drops.
You know, so I don't accidentally press ranks and then have like the most random thing. Oh, okay, triple drops. Who do I? So thinking of because you yes, fuck. Okay, best tornado to pull into the sparky. Okay, so because you're gonna pick lumberjack, so I go and pick E-bombs. Ooh, you.
Average elixir 4.5.
It's you're gonna pick Phoenix. I'll pick
Execution. What is this average elixir?
You're gonna pick
rocket.
freeze.
Pick rocket.
You picked freeze. I'm picking fireball. You picked Mega Knight. I am gonna pick.
How do you know what I pick? Everything is correct.
You picked Prince. I'm gonna pick Ice World.
He didn't pick Prince.
Who did we pick? Battle
Knight.
Knight awesome. Bro, because you literally just said I'm gonna pick all the legendaries. Wouldn't it be funny? Split E-bombs first play.
Yeah, that would be so funny. Oh.
Uh-oh. Oh, whoops, misplayed.
What is that? Full count everything.
It's
I don't have any buildings.
Why don't you have buildings? You should have picked buildings.
I didn't get any choices of buildings.
Bros. Dude, man, that Mega Minion is so valuable. Well, you're also Mega Minion.
Wait, I don't have any air cards.
Air counters.
Yeah.
Well, he doesn't
You do
have any
Phoenix.
air cards.
Phoenix.
Except...
Oh.
Phoenix, F Phoenix.
What?
I know he always picks threes for some reason.
How much elixir is he on?
He's on max. Now he's not on max.
You know the evolves in front of the Sparky?
Yes. He bombed the spot.
Unless you can tell me these two didn't really learn anything,
Oh, could potentially be true. Yeah.
given that, like halfway through they were asking what V of P was. I mean, no, V of N was.
Interesting.
You're gonna miss the print.
Guys, don't worry. Prove it yourself. It's fine.
It's kind of hard to figure the rest out without that, you know?
Oh, yeah,
Just
that's
a
true.
bit-
Look at how much elixir he's on and how much
This
elixir I'm on.
fundamental.
How much is he on?
I'm on 1 right now. Because of that Ram Rider. No, there's nothing to predict. Because he goes Mega Nut.
Or he's going to kite.
No, just a stall.
What? Freeze? What is he doing?
Thanks for letting me just save up for my E-bombs. No, I missed the E-bombs. Oh, never mind, it's alive. That's all that matters. Kaboom.
Oh, that did not work.
Doesn't matter, I just fireball. I thought I missed the Phoenix.
You missed the Phoenix.
What is that like?
It's still a full count.
Bruh. E-bombs.
Don't you stop breathing. You're breathing so terrible.
Princess to defend the E-bombs, bro. Broski, you've lost. You picked all your cards. You picked all
I
your
didn't get any
cards.
buildings on the choice.
Yes, you did. Instead of the lumberjack, you could have built in
Oh, crap.
Yes,
Yeah.
do Mega Drop. Do Mega Drop.
No, it takes so much time.
Did you record?
I'm still recording. Oh, do I stop the recording?
Oh, wow.
You can.
You went for Pekka.
Is it all done?
Yeah.
Oh,
He went for
I gave him 5 handouts.
Oh, very good.
Did you predict his Phoenix?
Wait, you're gonna go for minor.
Alright.